distinguished guests, scientists, research scholars, and participants. Gathered here to celebrate World Ozone Day 2026. On behalf of Gujarat Institute of Desert Ecology, it is my privilege to welcome you all on this special occasions. This year's theme, Strong Marine Protected Area for Our Blue Planet, remind us of our collective responsibility to conserve and protect our ocean and marine biodiversity for future generations. We are honored to by your presence and grateful to your support in promoting ocean conservation and sustainable marine ecosystem. Thank you for joining us in this important celebration. Now I welcome our Deputy Director Dr. K. Karthikeyan for welcome address for this event. Thank you. Hello.
Yes, Dr. Bera. Yeah.
Not sir.
Yeah. Respected chief guest and the distinguished speaker of today's presentation, Dr. Satyaban Vishwaratna. My esteemed, my dear colleagues, project staff, research scholars, and all the participants who have joined online, a very good morning to everyone. On behalf of the Director, Gujarat Institute of Desert Ecology, Bhuj, it gives me an immense pleasure to welcome all of you to the World Ocean Day 2026 celebrations. And like every year, World Ocean Day reminds us of the invaluable role oceans play in sustaining life on the Earth. Because oceans regulate our climate, supports biodiversity, and it provides livelihoods to millions of peoples and serve as a vital source of food and resources. This year's theme, Strong Marine Protected Areas for Our Blue Planet. It highlights the urgent need to conserve and strengthen our marine ecosystem in the face of growing environmental challenges. And Gujarat Institute of Desert Ecology, as an institution, we are actively engaged in coastal marine ecological research. And GUIDE recognizes the importance of the scientific knowledge, community participation, and policy support in safeguarding our oceans for future generations. We are especially honored to have with us Sir he's heading the Climate Application and User Interface Division of Indian Meteorological Department, Pune, and who will be sharing his expert insights on the role of climate variability in shaping marine biodiversity and the significance of marine protected areas in a changing ocean. And I extend my sincere gratitude to all the participants, organizers, and guests who have joined us today. I hope this program inspires meaningful discussions and strengthens our collective commitment towards ocean conservation and sustainable marine resources. So with these words, I warmly welcome you all and wish you a very fruitful and an engaging World Ocean Day celebrations. Thank you, and a warm welcome to you too, sir.
Thank you, sir. Thank you, sir. It is my pleasure to introduce today's speakers, Dr. Satyaban Vishwaratna. Dr. Ratna is currently serving as the scientist staff and head of Climate Application and User Interface Division at Office of Climate Research and Service, Indian Meteorological Department, Ministry of Air and Government of India. He holds an MSc in Oceanography and MTech in Atmosphere Science and PhD in Meteorology. His research focuses on ocean atmosphere interaction, climate variability across interannual and multi-decadal timescales, including ENSO, IOD, MJO, and AMO, and other and their influence on Asian monsoon. Before joining IMD, Dr. Ratna held a research position and several leading international institutions from 2010 to 2021. He worked as a climatic research University of East Anglia, UK, Jamstec, Japan, and CMCC, Italy, contributing to global climate research. At IMD, he is currently engaged in operational climate service such as seasonal forecast and so IOD monitoring in bulletin, sector-specific climate application and capacity building through training program at the Regional Training Center in Pune. He also continues his research on monsoon dynamics and extreme weather events while guiding PhD students and mentor internship and project work. Dr. Ratna currently serves on several international expert panels, including WCRSP Monsoonal Panel, Climate Dynamics Panel, WMO Task Team, and on National Framework for Climate Service, SAHF Working Group on Climate Service, etc. Through these roles, he contributes to the advancing international scientific collaboration on monsoon research, climate dynamics, and climate service for societal application. Today, Dr. Ratna will deliver and talk marine protected area in changing ocean, the role of climate variability in shaping biodiversity. Let us join with him on this topic. Dr. Ratna, now floor is open for you. Thank you.
Thank you, Dr. Behra, for these nice introductions. And I also thank all of you for inviting me to deliver this lecture. And I also thank you, Dr. Kanan, for these welcome remarks. So I just share my screen now. Yeah. Is my screen visible and am I audible?
Yeah, but it will make it is full screen.
I already made full screen.
Yeah, it is full screen. Yeah.
It's full screen. Okay.
Yes. Yeah.
Okay. All right, thank you. So at the very outset, I wish you all a happy World Ocean Day. And as you know, I'm a climate scientist where I study the role of ocean on climate variability. But as this year's World Ocean Day theme is strong marine protected areas for our blue planet, so I will try to link how this ocean is shaping our climate variability as well as biodiversity in this term. So as we just mentioned, I just briefly discussed, Raven, why ocean matters. Because it is a World Ocean Day. Before we are trying to study the climate variability or this marine biodiversity, we want to know why ocean matters. As we know already, this covers actually our 70% of Earth's surface that support our life on our blue planet. And we know that many factors we already studied, there is climate change, global warming, but where this warm heating goes up, because this ocean absorbs more than of 90% of the excess heat trapped by these greenhouse gases that helping regulate our global climate. And these oceans mainly drive it. For example, whenever we talks about this year's monsoon, there are a lot of talk about the ocean's role, for example, El Nino. So this is one example, best example, how this ocean drives climate variability and weather systems, that is including monsoons, cyclones, and the El Nino, La Nina kind of different things. And in terms of marine perspectives, this supports it supports rich marine biodiversity from microscopic plankton to coral reef and the fish, turtle, and whales. And this provides food, livelihood, ecosystem service that sustains billions of people worldwide. This is one simple example. We show the world ocean map. We know different ocean has a different climate factors. Not only it is affecting the marine diversity, the marine phytoplankton or zooplanktons, but it also affects the wind, temperature, rainfall over and the different parts of the world. This is how the ocean plays an important role for terrestrials and marine ecosystem. And with this brief discussion, we can imagine that a healthy oceans underpin a healthy planet. So this year's theme, actually, it is a World Ocean Day theme. The World Ocean Day organizations, what is the purpose of this theme and their motivations? The action theme is actually the strong marine protected areas for our blue planet. That means this will this guide global action over the coming years, because we need to take some action. We know there is already dangers for our marine lives or even a global climate. So it brings together the momentum of multi-year actions that catalyzing the ocean climate actions and protecting at least 30% of land, water, and ocean. They call it is a 30 by 30 because by 2030, at least 30% of the land, water, ocean need to be protected. That will be actually aligns powerfully with the recent rectification of the High Seas Treaty, where many United Nations works together on these aspects. So what are marine protected area? You may knowing all of this, but briefly I will mention one side. Marine protected areas are a defined marine, coastal and estuarine areas that are managed through legal or other effective means to conserve biodiversity, ecosystems, habitats and associated ecosystem services over the long time. This is one actually official United Nations of Environment. I tried to download from the one web. So we see that apart from the all the global ocean, only very small percent, they call only 6.35% of the global oceans covered by the protected areas region. So what exactly it is? It is actually ocean equivalent of national parks. This conserve biodiversity and habitats. This supports fisheries and ecosystem services, and currently only a fraction of global ocean which we indicated in this official MPF. So what kind of biodiversity is supported by marine protected areas? For example, as your organizations also works a lot of the coastals activities. So we know these biodiversity is supported, that is examples coral reefs, mangrove forests, seagrass meadows, plankton community, etc. This is a overall helps through the marine protected area. Otherwise, we know that we have several news every few days, few weeks, few months. We see how this due to climate change it is affecting coral reefs, mangrove forests, seagrass, plankton communities. So the international communities they realized that this marine protected areas, once it is a fully established, it needs an awareness so that we can improve the conservation of this biodiversity. Now the main topic comes actually climate variability and climate change, where as per my expertise, I will try to focus more on this. What is the climate variability and climate change? Because these are the two drivers. We most of the times, whenever we see news, media, people talk about the climate change. Climate change means many times people what has happened in the 30 to 50 years, and main people talk about what is going to happen in the next 30 to 50 years. But in between this climate change, there is a one important characteristics. It is called climate variability. I will explain along with this climate change and how they are different. So climate variability and climate change are reshaping ocean and atmospheric condition that is influencing marine, not only marine, it is a terrestrial ecosystem through changes in temperature, circulation, productivity, species distribution, and biodiversity. So climate variability means many times it is called a natural variability. For example, there is a year-to-year fluctuations. You can see that is a temporary. There is a if there is a value is high, means within a few months or few season or few years the value can be a go down. Then it is a fluctuates with a stable baseline. And there is a, for examples, the we talk about El Nino, Indian Ocean dipole, Maiden Ocean. These are all the part of this natural variability, or it is a called it is a climate variability. So, in relation to the what does actually climate change? Climate change actually long-term shift in the baseline. So that means this is the many times we already talked. There is a human-driven climate change. There is a long-term base. For example, 50 years ago, if we see the temperature of India, if we consider, remain to be much lower than this. But now after 78 years, we realize that temperature hasn't risen up. Even the global temperature hasn't risen up. The ocean temperature hasn't risen up. There is a shift in the mean temperature for a long time period. That is old. That is what we call as a long time change or the climate change. This is the way we can differentiate this, the climate variability and climate change. Because why we want to difference? Suddenly there is a warm temperature object or there is a cold wave object. Suddenly people link it with this climate change. It may be happen to the due to climate change, but every year not every aspect of the climate is not related to climate change. There is a natural variability that fluctuates within the seasons or years or a couple of multi years as well. This is another example we is a graphical way in the ocean perspective. Why we want to know climate variability and climate change. I just explained what is the difference between climate variability and climate change. These are the examples of El Nino or iodine that is happening in the ocean region, but it is affecting the marine as well as the terrestrial life. So what happened? Once these are temporary aspects, even though this climate fluctuation, for example, during El Nino time, sea surface temperature will be warmer. I will explain again in the later stage. So warm ocean is happening here. So in terms of Indian Ocean throughput means what happened? There is a warm sea surface temperature observed in the western equatorial Indian. So there is a marine productivity is influencing. So during similarly the intra-seasonal within a month or within there is a change in warming and cold in temperature. How they are affecting the ocean? That is affecting SST fluctuation. That will contribute to change in the wind, upwelling, variability in the productivity. Is where is the predictability? Then year-to-year fish, because El Nino and IOD they are contributing to year-to-year fisheries and species distribution and modulation the tropical cyclones and rainfall as well. Because this is I will also show in the later how the warming recess is impacting the rainfall over India. In such a terms, what happening? The climate change is a global driver. Means we know there is a ocean is warming consistently during the last 3 to 5 decades. Now we talk about the marine heat waves because it's a kind of the heat wave over land. There is a marine heat wave over the ocean that is also happening very frequently in these days. Ocean acidification is happening due to climate change. Sea level rise is happening and the decrease in the oxygen level is also happening. So what happened? That is how again the climate, this is the climate variability is impacting on the ocean. This is the climate change in the affecting ocean. Means we know there is a coral, many times we talk about due to climate change, corals and seagrass habitats are changed. Shift in species and raises and timing of life actually changes. Impact on the fisheries and food securities. And as there is a strong due to this climate change, we saw that sometimes cyclones are becoming extreme, sometimes here floods are becoming extremes. And this is the way actually again loss of coastal ecosystem and biodiversity is also impacting. This is the year climate variability, the changing ocean. Year to year it will change, but this is the climate change or impact on the ocean. There is a long-term changes that I will again briefly explain related to only focusing on the climate change. We know that there is a lot of debates about the global warming. So global warming that is not only warming the temperature over land, the warming the temperature over oceans. This is the temperatures surface sea surface temperature for the May 2025 related to long-term climate like 1985 to 1993. That means what are the temperature about 30-40 years ago? Most of the part of the oceans is already warming. This is the related in terms say NOAA, one of the international organization. The unit is a degree Fahrenheit, but that doesn't matter. We can see that all the red colors are temperature actually rising temperature. That means it is impacting the oceans as well as the land ecosystems. So this is the trend. We can see that as I mentioning how we can understanding the climate change. You know that is around about around 75, 80 or 100 years ago. We can see that normal temperature is quite below, but now this is steadily rising. So now the compared to the last century, the temperature is already warmed up around up to the 1.2 degrees Celsius. This is the way we can see that how there is a long time change in the world oceans. So how this climate I just explained briefly. For example, ocean heat contact, because the not only this I explained about the sea surface temperature. Ocean heat contact means if we got surface to the depth of 700, the upper layer of the ocean is also warming. So these was strong gradient or the strong increasing the ocean warming impacting not only in the marine ecosystem, it is impacting the rainfall temperature throughout the globe. And it is already discussed, for example, Many times see that due to climate change, the few decades ago, the corals, which is a very beautiful, now due to the ocean acidification, it has changed its shape and color. And due to the climate change, we see that this is the WMO, World Meteorological Organization, marine heat waves. Different parts of the globe already experiencing from category moderate, strong, severe to extreme marine heat waves. And due to the climate change, we can see that sea level rise. And those who are living along the coast, we already understand how these sea level rise is impacting this coastal community. But it is also not only we studied about the past climate, how this warming has taken off or warmed up the ocean and the land or the global surface temperature. But most of the global climate model or scientific base is indicating that the temperature will be rising up in the coming decades. For example, we see the based upon the amount of the warming, that is what we can accept. Many international scenario it is expressed. For example, this situation, what was happening around 30 to 50 years ago, already changed in terms of corals, fish productions, and sea lives. But when the temperature will be warming up about 1.5 degree, so there is a chances that there is a reduced sea ice, there will be a less marine biodiversity, and there is a chance at a coral reef recovery. But what happened? This there is a around after 2 decades, when the 2 degrees warming, the situation will be much worse actually. This is the what actually global scientific actually community is increasing. So what happens? But once this temperature is rising, there are some pieces they can adjust to temperature, warm temperature, but some this biodiversity or the fish community, they cannot adapt to the warm temperature. So they look for this colder temperature region. Although the temperature over the polar regions is also warming up, but polar regions temperature is comparatively low. So as a recent studies is indicated that there is a lot of species migrations toward the Atlantic or the north part of the oceans, where the temperature is relatively low. And it is also that because compared to the surface temperature, the bottom temperature is colder. So to fishes to need to be survival and due to the climate change aspects, many fish community or fish some species, they already found now recent years in the deeper ocean level. That is what it is known how these climate changes are impacting this marine species. Now, I briefly explained about the ocean aspects, but now I will explain about the atmospheric aspects because I am a climate scientist. I focused on the as part of this my job in the India Meteorological Department. We continuously monitor this climate variability and how it is impacting the day-to-day weather, month-to-month seasonal climate or long-term climate as well. So when I briefly discuss climate means this is a seasonal variability or year-to-year variability. For example, this is climate variability means major climate variability which is impacting our Indian continent. It is known as a El Nino. I will explain in detail. Then there is on the Indian Ocean. El Nino means it is in the Pacific Ocean, and the Indian Ocean dipole, which is in the Indian Ocean. And another is a Maiden-Julian oscillation. I will not have time to explain in detail because this is an intra-seasonal oscillation throughout the equator. Every 40 to 60 degrees or 30 to 60 degrees, one rainfall zone or convection zone move will be eastward, so that it will impact the marine as well as the land due to the rainfall and temperatures. So this climate variability influence weather, ecosystems and biodiversity across land and ocean, including the variability of the Indian monsoon rainfall. Now we'll go to the in detail. So now we have shown that there is a lot of attention in a media, newspaper. You must have every day all the media. Sometimes it's too much they explain, but they say that El Nino is coming. El Nino means what happened? We talk as a climate point of view. El Nino means this is the El Nino, where the actually sea surface temperature is warmed up or heating up for a couple of months or a season in a particular year. So whenever such warming is happening, this warming also influence the atmosphere. So as such, whenever we discuss about the El Nino and La Nina, we talk as a ocean atmosphere coupled phenomena, just like a coupling. Ocean atmosphere coupled phenomena, they normally together known as a El Nino Southern Oscillation. Because this, when the El Nino was discovered, later what has though that corresponding overlying atmosphere is also changing. So whenever we talk about El Nino, ENSO means you can talk about the El Nino or you talk about the La Nina. Because 2 years ago there is a La Nina. This year El Nino. After again 1 to 2 years there will be El Nino or there will be another La Nina. So ENSO is a periodic fluctuation every 2 to 7 years in sea surface temperature and the overlying atmosphere across the equatorial Pacific. Here is our Indian Ocean. Here this is the actually Pacific Ocean. ENSO is one of the most, why were important, why media, scientific communities, alerting every community that El Nino is coming, we need to be prepared. Why? Because ENSO is the most important climate phenomena on Earth that changes the global atmospheric circulation, which in turn influence the temperature and precipitation across the globe. ENSO is a, I said, coupled phenomena. Atmosphere will often influence sea and ocean will influence the atmosphere. Again, I will show with a different schematic. So ENSO is a 3-phaser because when media is not talking about El Nino, when is media or scientific are not talking La Nina, there is a neutral phase. If there is El Nino, sea surface temperature will warm up in the central and equatorial eastern Pacific. There is a warming. Another time, what happened during La Nina? Instead of warming, sea surface temperature will be colder than the normal for a couple of months to couple of seasons. This is the way it will call La Nina. So now we are approaching El Nino, which is already nearly setting in, so that we'll see how and why El Nino is important. We'll discuss now. So we need to monitor the strength because, for example, now many media, newspaper or scientific community also they talk about the super El Nino. What is super El Nino also? Why I will try to explain. So this is actually Pacific Ocean. Just like rainfall, we need to measure a unit. Just like sea surface temperature, oxygen level, everything to monitor it is a weak or strong. Even our measuring a temperature in our body, everything we need a measure or we need a unit. So similarly, to monitor the strength of El Nino or strength of La Nina, we scientific community, we try to average the sea surface temperature over the equatorial Pacific region. Some region of the world, some of the organization, it is a Nino 3 region, little eastern side of the Pacific. Some follow the western side of the Pacific. In India, most of the work related to the Central East, that is all called the Nino 3.4 SST. So we try to monitor the sea surface temperature over this region, how it is evolving. So this is the sea surface temperature over this Nino 3 time series, starting from January 82 up to the April 2026. For example, and we have a climatology, we have a normal, we subtract the normal from the every month. So whenever this month's sea surface temperature is warmer for a couple of long time, we call it is a El Nino. These are, but El Nino, it will not always happen. It will not happen. For example, what happened? If these are, because these are warmer than the normal, these are the warmer than the normal. This is the year 2019, 17, 19. These are the 2015 and 16, and recently 23 also. These are warmer than the normal. So not only because sometimes these are the period also warmer than normal happen. So when we talk about El Nino, when the temperature is warm around 0.5 degrees Celsius compared to the normal, and it is continuing for the few years, then we call it a El Nino. Similarly, when the temperature is the below normal up to 0.5 degrees Celsius, these are the we called actually La Nina. This is the way we monitor the El Nino La Nina. So sometimes the strength of El Nino will be stronger, or sometimes these are all the natural climate mode. These will be sometimes weak in the intensity. So, for example, when in terms of El Nino, whenever there is a sea surface temperature 0.5 degree to 0.19 degree, we call it a weak El Nino. If it is a 1 degree to 1.5 degrees Celsius, we call it a moderate El Nino. Similarly, if this threshold exceeding 1.5 degree to 1.9 degree, we call it is a strong El Nino. And here the anomaly is 2.0 is actually greater, means it is a very strong. For example, whenever this sea surface temperature will be exceeding the 2 degrees Celsius for a couple of months, we call it is a strong, very strong El Nino. But there is a not everybody talk about, but there is a link. Some people they discuss whenever there is a very strong El Nino, we call it is a super El Nino. That means now it has not occurred. Most of our climate model is indicating that this year sea surface of temperature over this Pacific Ocean may exceed the 2 degrees centigrade. That means that the reason they talk about this super El Nino comes. But super El Nino to comes, now it is no El Nino, even a weak El Nino is not at there. So to reach super El Nino, it will take at least 3 to 4 months time. So by that time, it will September, October, November. At that time only, we will be able to know whether we reach it to the super El Nino or not. So according to C, we see that there are super El Nino means 1982-83, 97-98, 2013-14, and these are the actually 23-24. These are the kind of, this is one of the very short and weak. It has not reached exactly, but other three are the kind of super El Nino. So why we call it is a super El Nino or El Nino? How it is related to ocean atmosphere interaction? For example, normally this El Nino, if there is no El Nino, normally sea surface temperature is actually is warm over the western equatorial Pacific Ocean compared to the eastern ocean. So at that time, strong wind blowing this warm water accumulating in this up. Normally what happens? Here the upwelling, normally climatological eastern Pacific is a good upwelling. So good upwelling region means it will bring cold nutrient rich water to the surface, which is good for the marine diversity or fish productions. But what happened during El Nino? This warm sea surface temperature warm actually shifting to the central east. Central east means what happened? The warm water is absorbed in the western equatorial Pacific. It will reach to the eastern Pacific. So what happened? The upwelling will be weak during the time, so that fish production will be comparatively reduced due to the winds. The wind which is blowing from east to west will reduce. The rainfall and convection what was observing in the western Pacific Ocean, it will be shift to the central Pacific. This is in such due to heat released in the top of the atmosphere, it will change the circulation pattern worldwide. This in turn will impact the rainfall over India and the worldwide. This is another example of La Nina. So La Nina time what happened? There is a strong upwelling will be observed in the comparatively observed here, but at the same time the whatever the warming we observed during El Nino, warm sea surface temperature in the central east Pacific, it will again shift back to the western equatorial Pacific Ocean. There will be more convection, more rainfall over the western equatorial Indian Ocean, eastern Pacific Ocean. This will help because this is a large convection. India is lying close to this event. This will impact actually the more rainfall. This is the simple. But why we are again impacting study? So this is the rainfall anomaly map, means compared to the climatology in the rainfall map from 1872 up to 2023. For example, we can see many time when there is a below normal rainfall or below normal rainfall, because all the lower lines, these are the below rainfall. So scientifically, we try to understand that whenever there is a below normal rainfall, these years are coinciding with El Nino, you can see, or it is a dry years, it is called. It is a maximum time. Below normal rainfall over India is coinciding with the El Nino. That's the reason this year also, because model is forecasting, scientific community is indicating that the El Nino is approaching, El Nino is coming. There is a high chance that by understanding that this year will bring below normal rainfall. So similarly, when there is a more rainfall over India, there is actually, these are associated with La Nina. So La Nina may help to bring above normal rainfall or good rainfall over India. This is the way we are linking El Nino, La Nina, or climate variability to impacting the rainfall variability over India as well. So you talk about not only this El Nino impacting the rainfall and temperature over the India only, it has a global impact. This, for example, we call it a December, January for the winter season, June to July is a El Nino. Where is a El Nino? You said even winter time, this color indicates that most part of the Indian region will be warmer than the normal. Parts of the Northern America, part of the East Asia, part of the South Africa will be also impacted. South America, that indicates that El Nino can impact throughout the globe during winter. Similarly, the El Nino can impact throughout the globe during the summer season. Impacting means summertime in June, July is a monsoon season, rainfall will be below normal. East Asia, rainfall will be below normal. Here will be dry, warm and dry. This will be above normal, because here above normal means sea surface temperature will be nearly shifting to this region. So this is the El Nino impacts over the globe. Similarly, La Nina impacts. La Nina means La Nina also has a global impact. It will impact, bring cold wind during the winter or more rainfall in the winter. Similarly, during summertime, it will bring actually above normal rainfall in India and many other regions. This is also again telling that not only El Nino, La Nina can also influence the global climate. So, due to this reason, we continuously monitor El Nino, and we try to predict actually. At IMD also, we continuously monitoring, because we know that compared to predicting the rainfall and temperature, monitoring ENSO is a more advanced, or the predictability of ENSO is a very high. So that because we can predict El Nino, La Nina month and in advance. So because El Nino is about to come about 4 to 5 months global climate model indicated, even in our IMD model predict models. This we are monitoring. See, this is the monitoring. Now, this year actually in the last few months the temperature is colder, but now since actually April and May, the temperature is warming up. That means to reach the threshold to declare El Nino, we need the temperature of 0.5 degrees Celsius. That means by end of this month, when because now we are now we didn't monitor, but when it is up to April, when the month of May we include, there is a high chance that this reached already Nino region, ENSO region already reached the El Nino threshold. But as such, we cannot declare immediately El Nino. To El Nino to declare means it need to evolve for at least continue few months. Once we know that El Nino, the warming sea surface temperature already impacted the atmosphere. This is the current latest months up to 30th May. We can see that throughout the Pacific region, the sea surface temperature is already warming up. That means it is clearly at the same time Indian Ocean, many regions also we can see warming up. This indicating that it is impacting our global climate. What is the plausible scenario? Because most of the climate model is indicating that, see, it is El Nino. For example, El Nino is approaching, around 90% of probability that El Nino will approach during June, July, August. Then the strength is agree around 100%, because by August, September, October, November, there is a high chance that we will have a established El Nino. So what happened? IMD, this is the IMD's forecast. We also use various climate model to issue the rainfall forecast. Our model is indicating that many parts of currently in India, there will be below normal rainfall. This gray, yellow and orange color indicating that this is a below normal rainfall. That means climatological, how much rainfall each this region is to get. So some of the regions will have a much below than that. That may lead to the drought season. So for example, as a climate scientist in IMD, what we do, we regularly monitor. For example, monsoon we need to monitor. For example, what is the start, because ENSO is one, El Nino, La Nina helps to understand the whether it will be above normal or below normal rainfall. Before the season we try whether there is El Nino. No, there is a El Nino means there can be La Nina, there can be no La Nina or low El Nino neutral. There is El Nino because this year is a high probability of El Nino. In the month of April, we realized. So that means once there is El Nino, there is a other climate mode also impacting to the Indian rainfall is a Indian Ocean dipole. Whether it is a positive IOD or it is a neutral IOD or negative IOD, because along with the El Nino, this Indian Ocean dipole or Indian Ocean sea surface temperature also either exaggerate the situation or complement the situation or try to oppose the impact of what is observed from the El Nino. So accordingly, we try to monitor statistically what is going to happen this year's monsoon. For example, we talk about that. Now last few slide I am approaching. So what happened? Many times people talk about this super El Nino. Even 97 also there is a super El Nino, but that year actually India fortunately doesn't have any serious impact. Rainfall received nearly normal, 100%. How much the rain we supposed to get, although there is a special variability, but 2015 there is a super El Nino. That year actually 14% deficient rainfall occurred, which is seriously impacted our agriculture. This is the way that El Nino, sometimes super El Nino means there will be impact, but that doesn't matter always that super El Nino means super impact will be there on that. That is the way in this slide I try to explain. So when there is El Nino, at the same time, Indian Ocean sea surface temperature approaching, another is actually Madden-Julian oscillation. This is also another ocean atmospheric phenomena. What happened? This Madden-Julian oscillation on climate mode, every few days, 30 to 60 days, it will move from Indian Ocean, it will move from the Eastern Indian Ocean, it moves from maritime continent, it moves from Western Pacific Ocean and Pacific Ocean. This is also strongly impacting the marine life as well as the terrestrial life. That's the reason I just in one slide I explained that. This, for example, sometime 1997, because of super El Nino, we didn't have a much impact on the rainfall, means this MJO also helped to have a good rainfall. But 2015, this MJO didn't favor, that the reason we received much less rainfall. So social impact we want to show, there is a whenever ENSO and IOD, we know that there will be impact rainfall. Rainfall means groundwater shortage may happen. So reservoir storage will be impacted, flood will be impacted, and there is chances of drought due to El Nino. So this will be impacting crop production. This is a providing health impact also may be there. So due to temperature, sometimes many people they discussed this year due to El Nino there is a heat wave, but this year El Nino at that time not there. It may happen that during the next El Nino, next summer, March, April, May, due to this ongoing El Nino, next year the temperature may be already warming up. So it is going to be happen due to rainfall temperature. It will, the societal impact means it will impact on the water resources, it impact the health, impact on the agriculture. This is the way the ocean is influencing the society in a different way. For example, many times these are the rainfall. For example, there are past 9 years we try to monitor. The rainfall also will vary. It will not that every El Nino, many El Nino year, this were northwestern region, Gujarat 1987, 2002 will be warmed down. But in 2015, there is some good rainfall. 2023 is a good rainfall. Because this is very complex that we can take all India, there will be below normal rainfall, but the special variety is such a high that few years, but many times we can say that 82, Gujarat region, we consider 87, 91, 2002 and 2009 there is a below normal rainfall Gujarat, but few years even El Nino 97 and 2015-23 there is a above normal many parts of the Gujarat. Similarly, whenever there will be a we saw El Nino means that doesn't means we will have a very less rainfall, because there is a chances that many heavy rainfall episode also we are going to experience. So that we also, even though there is El Nino year below normal rainfall, we may need to stay prepared that there may be chances of error. For example, see, even 97 there is a many heavy rainfall events. 2002 many heavy rainfall in Gujarat. Even 2023, 2015 these are the around 5 to 7 heavy rainfall events. So there may be some flood situation also may arise. We need to stay prepared. This is one agriculture perspective. El Nino means there will be below normal rainfall, so that it will have a below normal impact on the agriculture as well. And what could be the possible, because now we are talking about the 2026 monsoon, so and we talk about the El Nino is approaching, so there will be a reduced seasonal rainfall. There could be a tendency to below normal rainfall. So there is a increased dry spell. That means it will rain for 2 to 3 days. Again, 10 days it may not rain in the monsoon season. So then definitely it will be an impact on the agriculture. So if there is a no rainfall means even monsoon season we sometimes we face we feel pleasant weather, but due to the if there is a no rain, dry condition prevail, there is a high temperature condition, heat wave like condition may continuously we experience. And again increased rainfall, sometimes heavy rainfall, sometimes dry, sometimes heavy rainfall, sometimes high season, so that there will be a impact on the actually flood and management will be very difficult. So why does this El Nino matter for this society means, as I explained, this will impact, there is a chance due to below normal rainfall, it will be impact agriculture. Due to below normal water resources means water resource is important for agriculture, drinking water, many city may that due to less rainfall, there will be everyday water supply may not be provided based upon the water reservoir situation. It will have a energy impact, because those who are managing by hydropower generation, due to rainfall, due to less rain, it will have a impact energy. Then it will have a impact also warmer conditions, it may impact health, and this may again weak monsoon year, heavy rainfall, and that may will have a disaster risk reduction. And again I am coming back to the I started with the marine biodiversity, then I discussed with the climate variability and climate change. Then when I talk coming about monsoon and marine diversity, because this monsoon is also strong link with the marine diversity, because we know southwestern monsoon means it will bring strong low level wind from the Indian Ocean to the towards the land. So once this strong low level wind, these regions will be favor of the upwelling. Upwelling means cold nutrient rich water will be risen up from the surface. So once this I said the southwest monsoon will be like this way, this will cause to the upwelling. Once there is a upwelling, it will increase the nutrient over this region. You can see once the nutrient increasement, this is actually phytoplankton bloom. Once phytoplankton bloom means there is actually fish productivity will be increased during the monsoon season. In that way, it is controlling the monsoon is controlling the biodiversity in this different way. So I wanted to mention that monsoon variability influence not only the rainfall over the land but also marine productivity, fisheries, and biodiversity in the northern Indian Oceans. So there is a towards climate resilient marine conservation means we need to actually monitor the climate drivers. I said not only climate, we are monitoring climate change. We need to monitor the climate change, climate drivers, how El Nino, IOD, then strengthening the ecosystem resilience. We means a flexible plan based on the monitoring science, network and connectivity means well connected MPA, marine protected area, how to protect different ecosystems and how monitoring. And this is the way why science policy community leaders, and this is one example. Now many awareness program where you have organized this World Ocean Day, so that we base upon the it will link to the policy study. So these are the actually this is the final or key takeaways from my slide. I want to say the ocean plays a fundamental role in regulating climate variability. I am explained from seasonal to internal time scales, and ENSO and other climate variabilities such as Indian Ocean dipole, Maiden oscillation influence the sea surface temperature, ocean productivity, and monsoon variability. And climate change is altering the climate change. I said this altering the baseline state of the ocean through warming, acidification, and marine heat waves. I explained already. Then the changes in ocean condition directly affect marine biodiversity and ecosystem functioning and fisheries. And protecting marine biodiversity requires not only the understanding both climate variability and long-term change. The way I explained that the climate variability, how it is occurring, how it is predicted. So similarly, the climate change, we know how in the future climate change it is going to impacting. So my final thank you. See that this protecting marine biodiversity requires not only protecting only the places, so we call it a marine protected area, but also understanding the changing ocean that shape them. Thank you very much.
Thank you, Dr. Satyavan, for your insightful and informative presentations. Your valuable knowledge and expertise on the topic have great enhanced our understanding. We appreciate the time and effort you invested in your sharing your experience and research finding with us. Now, floor is open for discussion.
Any questions from the staff scientists or the staff? Dr. Satyavan, I have just a couple of things to ask you.
Yes, please. Yeah.
One thing is like, thank you so much for detailing about the, not only about the ENSO, which is the El Nino and La Nina, but also about the Indian Ocean Dipole and the MGO also, which many times we didn't get to know during any kind of, presentations on this aspect. Thank you for including that in that about detail. And if you could recommend only one priority action for the policy makers to protect the oceans, what that would be as a climate scientist?
Main thing is that many places already we see the strengthening our observations, because we need to monitor the ocean surface as well as this sea surface, sea characteristics in the different level, because we have seen that marine species are migrating one region to other regions or migrating to the different region. So the strengthening the observation system is the most priority, so that we can better monitor our ocean, so that we can know that how it is impacting our biodiversity. That's the way I can say the most priority area.
Priority action. Okay.
Yes.
So at one point of your presentation, you said you will shift to the atmospheric side, because that also is important in terms of the temperature and other things. And because and we also often hear that climate change is an atmospheric problem. Would it be more accurate to say that it is an actually ocean problem, considering that the ocean is absorbing most of the excess heat and carbon dioxide?
Yeah, because why many people we are talking it is atmosphere means we most of that leave about the, and as we know the climate change are attributed to the actually anthropogenic or the man-made problem. because many people are living on the land, we discussed that this lot of carbon emission or greenhouse gases is impacting the climate change. That's the reason, as we correctly pointed out, the 70% if there is a ocean, this helping the most of the impact that could have been happened had the ocean we not observed the oceans. We in the land could have very far rich consequences in terms of temperature and river variability and many other extremes. So we should not talk about either it is a land or either it is a global problem where the land and ocean both are, because we know that ocean lives are, ocean biodiversity is already impacting. At the same time, climate change is also impacting over the terrestrial ecosystem or the biodiversity of the land. So it is a global problem. That's the word I can best say.
Yeah, yeah. Thank you so much.
Hello, Dr. Ratan. Thanks for the informative information. So I have only one question regarding this one, especially on Indian Ocean dipole, right?
Yes.
What is the interaction between Indian Ocean dipole interact with El Nino? Especially, they are predicting 2027 is a drought maybe happen to Indian coast, right? So, what is the major role of Indian dipole? So, I want to know. Then this is the first part. Second part, what is the main drivers we can use to analyze this kind of problem in especially in the coastal of Indian oceans? So, this is my 2 point questions.
Yeah.
Thank you.
Yeah. See, for example, we always study about these two climate modes. Either we discuss about El Nino and another IOD. Main thing is that they are originating from the different oceans, because we know El Nino is a Pacific Ocean, India Ocean dipole is a Indian Ocean climate mode. Whatever the situation may be, El Nino is the most important climate driver in the ocean that is influence the climate not only in India but different parts of the world. So normally what happened, the El Nino, the life cycle is, for example, different. Now the El Nino is already, it is the now June. So starting from sometimes April, May and June, the onset of the El Nino takes place and slowly building up to the monsoon season. Sometimes during June, July or July, August or August to September, like that way the El Nino will be influenced. But the Indian Ocean dipole's characteristics is different. This will onset sometimes in July or August and peak its intensity around August, September or October. So then it will subside during November. So most of the time the Indian Ocean dipole and influence in the second part of the monsoon. And what happened, this El Nino, again I explained, 1997 is the classic example. There is a what happened, El Nino was there and the positive Indian Ocean dipole was there. I was explaining. So what happened, this is the classic example, 97 and 2015. Here the blue color indicating positivity and here blue indicating positivity. So what happened, both were El Nino, both were positive, both were the super El Nino. But at the same time, this year what happened, many papers have finded that positive Indian Ocean dipole helped to reduce the negative impact of the El Nino. But in that case, 2015, due to the sea surface gradient or the intensity of the Indian Ocean, that could not help the way it has helped 97. That's the reason whenever we are monitoring only El Nino, we realize that only El Nino or only IOD may not help. So sometimes within this season, what is happening, that is also drives the overall monsoon system. That's the reason we wanted to carefully monitor this Medellin oscillation. So again, the second question means El Nino is a impact. So this is a what happened. El Nino is a delayed impact. Sometimes it will help to shift the warming of SST over the Indian Ocean. So the warming of the Indian Ocean due to El Nino will remain for a couple of months ahead. So that even though El Nino happen in Pacific Ocean, the coastal regions, due to the ENSO impact, the sea surface temperature variability it will happen. That is also yet where very lot of change. If there is a sometimes positivity, sometimes not happening positivity, accordingly the sea surface temperature also in the coastal region changes. This is what I wanted to explain in terms of the two questions.
Dr. Ratna, some questions in chat box. First question: can you say all natural calamities are only responsible for climate change?
Sorry, sir.
Can you say all natural calamities are only responsible for climate change? Some chat questions in chat box.
Okay, I want to just. Due to climate change, ocean levels are often found rising, but if we can all natural calamities are only responsible for climate change. No, people are telling that due to climate change, natural calamities are appearing, not natural calamities contributing to climate change. Because or maybe the question may asked indifferently, because we see large number of natural calamities are happening and the intensity is increasing compared to the last many decades. That the reason we are talking about that climate change is increased the intensity of and the frequency of the natural calamities or the extreme weather events.
And
I hope I am clear in that question.
the second question is due to climate change, ocean level is often found rising, but few locations it was recorded the sea is going far away. What is the possible reasons?
Yeah, see, for example, same thing. It is what happened. These sea surface level, sea level variable is different. Just like in the as I explained, whenever explaining monsoon, even though there is El Nino, everywhere the not above normal rainfall, everywhere not of the below normal rainfall. Sometimes the local processes are also influencing. But why we talk about the sea level point of the rising? Because the rising is dominated in the many parts of the world except a few locations actually. That's the reason we see that sea level rise, the coastal erosion takes place in many places. That's the reason we talk about the majority of the sea level rise, but where it is maybe in the below, I am not much aware of that one actually.
Another
But
question about dry spermer. Raise your hand. That's please ask. Hello, Rajesh. Okay. Another question in chat box. How can climate change impact on livelihood sectors such as agriculture, fisheries, and livestock?
yeah, see, as I discussed, climate change is impacting means in if we talk about the agriculture is dependent upon the water. But what happened? The climate change once happening, it may happen that many parts of the region will be dry. Some of the climate model indicating. So once it's dry, below normal rainfall, there will be impact on the agriculture. In some of the climate model is indicating that the rainfall intensity will increase. For example, rainfall, we need a moderate rainfall for agriculture. If it is too dry, it will have impact on the agriculture. If it is too wet, for example, it is a excess rainfall, water will be accumulated, then it will be impact on the agriculture. So similarly, I can explain what a fishery and livestock. Why we explained that if the sea surface temperature is rising, because just like we need a comfortable temperature zone, the fish species or marine species also or livestock also they need a threshold temperature where they can survive, because of the region, whenever such climate change the temperature is rising, they cannot adapt to such a warm temperature. They migrate to the colder temperature area or the colder temperature in the north or south or colder temperature in the deep. This is the way climate change is impacting. Wherever people used to do where is a good fish were available fishes, now it is not available, maybe due to climate change. This is the way actually it is impacting the agriculture, fisheries and livelihood.
Hello.
Yes, yes, please.
Thank you, Dr. Satyaban, for your good lecture. I have one question in this. Not many times what happens that whatever we are predicting based on the our climatic data, but it is in reality it may not sometimes accurately observe on the ground. Whereas if you see in the western world they are predicting something, then it is really happening. So what could be the reason in our case why it is happening? So can you have some idea in that?
Yes, yes, it's a very, because many times this awareness is required. I'm happy that you asked this question. The best thing I can say, first thing I'm telling that whether is the western regions or eastern regions, is a different factors. Because why I say, for example, now the rainfall forecast we have given below normal forecast, it is not depends upon only one climate models. It is not only the models from India. We used 15 climate models that includes from the Japan, Germany, UK, USA, because we are working as a global scientific community and many meteorological centers. We are working together on the umbrella of World Meteorological Organization. It is not like if the rainfall fails means, because these are the global model. That model means the same model they use for the predicting weather, rainfall and temperature for US, the same model you are region. That means it is indicates that if the same model is forecasting rainfall and temperature of a proper region in a western region, if it is not able to same model forecasting means, this is indicating that complexity of the ocean and atmosphere happening in the tropical regions. Not only in India, many tropical regions have this problem, because there is a strong, because extra tropical climatology, those who are showing the little toward the north, they modulated by the actually a consistent weather system. So, but here actually our weather system, due to warm temperatures and the frequent convection, the temperature, these weather systems work differently to the western region. Otherwise, if we know that there is some failure means, same we could have taken help from the because this our model is failing means, now we could have asked any other countries that because to provide accurate forecast here. And now because I myself, I worked in UK, I worked in Italy, I worked in Japan, I bought a technology. I could have asked similar, our government could have asked say, all the agency to come and help like that. That means I wanted to tell that this is the complexity of the weather in this part of the world that drives to the atmosphere, that contributes sometimes to not accurately predicting the weather. But there is a consistent effort while the worldwide community that the forecasting still has been increased, and we hope that it is expected to increase, the accuracy will be increased in the future.
Uh, in that one more thing I have to add. Can we say that model is okay? We are getting world models, okay, but do it is some relevance with the data which we are not exactly getting in our country?
No, actually, see what happened again. Forecasted all generated based upon the model output. For example, this is the whenever we talk about the forecast means, if it's a within a 1 to 2 days, this forecast can be generated based upon the current observations. But if it's a forecast beyond 1 week, 10 days, 1 month, means it is completely rely on the model data. The computer, whatever simulating the all the physical processes, it's generating whatever the value and reliable tenable, and with some atmospheric and meteorologist experience, we provide the data. But what happened? I agree that some many part of the in India, for example, parts of the desert region, part of the high topography region, we do not have the enough data. For example, sometimes a parts of the Uttarakhand, Himal region, or sometimes some of the desert region will not have the data. These unavailability of data that may influence the some part of the improving the forecast accuracy, but that may not be the only reason that required for the improving the forecast accuracy.
Okay, thank you very much.
Dr. John, some question in chat box. How is climate variability in the Arabian Sea and Bay of Bengal affecting phytoplankton dynamics and breeding cycle of economically important fish species along the Indian coast?
Yeah. See again, this the ocean biology point of view, I may not expertise, but I can again tell that due to this climate variability we talking means, one climate variability means we talk about the three important climate modes again. Either it is El Nino, the sea surface temperature pattern will change over the Indian Ocean, close to Bay of Bengal and Arabian Sea. Another is Indian Ocean dipole, because there is a SST gradient during positive Indian Ocean dipole. Western Indian Ocean and the Arabian Sea side will be warm sea surface temperature. And Eastern Equatorial Indian Ocean side it will be, or Bay of Bengal side it will be cold sea surface temperature. That sea surface temperature will be influence the phytoplankton dynamics or the breeding cycle, because if it is a ENSO related sea surface temperature warming, sometimes these breeding cycles they need a particular threshold values, or the phytoplankton dynamics threshold value. But what happened when the warming pattern, the shifting pattern changes from the Western Equatorial Indian, if it is a good, but if it is strong warming, then all this phytoplankton breeding cycle will be eastern side where the cold surface temperature is available. But whenever the negative Indian Ocean dipole is observed, then warming will be towards the Bay of Bengal side. The cold temperature will be over the Arabian side. In this way, the breeding cycles will be changed. That will have a seasonal cycle related to El Nino and IOD. And within the season also, the onset of El Nino or the onset of IOD also is going to influence this phytoplankton dynamics and breeding cycles.
Thank you,
But
Dr.
there is a very close really, because what I'm sometimes these biology community and atmospheric community they have not worked in together in detail. This indicates, this last questions I mentioned, this is a recent question which you asked, it indicates that there is a climate scientist and this ocean biologist, they need to strongly work together to understand how this climate variability is influencing these phytoplankton dynamics.
Thank you, Dr. Ratna. On behalf of Guide, now welcome Dr. L. Prabhadevi, Scientific Advisor of Guide, to give vote of thanks.
Good morning to all. I take this opportunity to congratulate the organizers of today's webinar for arranging such a very informative and informative talk on this day, particularly on the climate aspects on this Ocean Day, World Ocean Day. In fact, we are fortunate to get such a personality today to address us on the various aspects of climate change and the need for protecting the protected areas, that is conservation of protected areas. And he has explained what's the reason behind the necessity for conserving our protected areas and to have more biodiversity in the oceans. And also, I'm thankful to you, Dr. Bishnoy Ratna, that we could able to understand a lot of information regarding the relationship between protected areas and biodiversity, and also climate variability and climate change, how this happens and how this climate variability and changes over the oceans affects the livelihood as well as on the land productivity and the health of human beings. That is a very good information. And also, I personally thank you and also I appreciate you, sir, for the presentation of your talk. The slides you have prepared is very excellent. And I hope this itself is also a takeaway for our staff members in their future presentations. And very excellently, you focused on the impact of climate change, the El Nino La Nina phenomenon on fish migration and productivity, and thus how it impacts the livelihood of the people over the land. And also, I'm very happy, and actually, I felt like that I am attending after a long time very good physical oceanography class on climate and ocean aspects. Thank you so much for joining us, considering our invitation, and we are grateful to you, sir. Thank you. And I'm also thankful to the management and also the organizing committee of Marine Division for attending this, arranging this webinar. And also, I thank all the participants who had very good interactive session. And we are all thankful to you for the participants. And once again, I thank you all for this participating in this webinar. Thank you.
Thank you, madam, for your nice message. Now the webinar is officially declared as closed. Thank you all.
Thank you. Thank you.
Thank you.